Hi, I'm Brent Yance, a software developer with LAS. In this video, I'd like to go into a bit more detail and add some more context to the video sense-making section of our 2026 call for abstracts. First off, this isn't a brand new area of research for the lab. Next year, we're planning on building off of work we're doing right now. This year, we're focused on two main areas of research within video. The first is video summarization and search with VLLMs. In this area, we're working to make it more feasible to search and understand large varied video data sets. In these cases, we're aiming for really generalizable solutions since we don't usually have good labeled training data to cover these varied data sets. The second area we're focusing on this year is video activity detection. This work really takes over once a user has narrowed down their large data set into a more focused subset. From there, users are often interested in monitoring that data over time, looking for specific objects, activities, or just anomalies, things they don't expect. In 2026, we're aiming to build off of that work in a few different ways. I'm going to quickly skim over a few of those problems we're interested in, and then go back and put them in context. First is improving our ability to quickly build an understanding of a new data set, even if that data set is large and varied. The second is allowing us to combine text and example-based search for video. The third is enabling us to improve video triage over time with active learning. And finally, we'd like to put these different capabilities together to let us automatically prioritize the most important new content as it comes in. So to add some more context for these goals, I think of them as fitting into two general problem spaces or two steps in one larger video triage process. These also line up with the two areas we're focused on in 2025. The first of these two areas is making video searchable. This is the first problem space we hit when faced with a new data set. In more detail, given a massive varied set of videos, we could be talking tens of thousands of hours of video. We want to first understand what we have at a high level. Before we can start trying to find a needle in a haystack, we first need to understand what we have available. We could easily have tens of thousands of hours of video of very different types, everything from professionally edited videos to dash cams to stationary cameras to videos someone recorded on their phone. The question we have here is how can we take inventory of what we have without needing to watch thousands of hours of content? From there, once a user has an idea of what data is available, they'll want to start searching for content that's meaningful to them. At first, they might not have any examples. So how can we enable them to search through these data sets with only a text description of what they're looking for? After a while, they may find a few good examples of what they're interested in. So how can we take advantage of that to kind of iteratively improve the analyst's ability to find more meaningful data? Can we use those examples to enable a combined text and video-based search? All of this should allow the analyst to narrow down a more highly varied data set to something smaller and more focused. And that leads us to our second focus area, activity detection and video summarization. So let's start with an example of what this could look like. In this case, we can use the case of pet cameras around the house as an example of a more focused subset that we get out of that first problem space. So what could we be interested in? Well, I have some pet cameras around the house to keep an eye on our dog. Some people might have a Ring camera in the front of the house, maybe one watching the backyard. And 99% of the time, these aren't recording anything of value. The rooms are empty, there's just normal activity going on. All it's really doing is burning local storage space, taking up bandwidth, and making us pay for cloud storage of footage of empty rooms. And really, there's our first problem. Given this more narrow set of pet cam videos, how can we enable first pass triage at the edge? Can we strip out the 99% of the time nothing's going on to save storage space and bandwidth? Could be on the cameras themselves, could be on a device in the local network. Either way, we're saving bandwidth and storage space. And at the end of the day, there's no way I'm going through all these 24 hours of video from each camera manually. Really, what I'm looking for is a summary of what happened, and ideally the ability to ask questions. Did anything unusual happen? Did my package get here? Did someone try to break in? That kind of thing. We do need to balance this though. So far, we've talked a lot about saving bandwidth and enabling this kind of high-level retroactive review. That's not the main reason I have these cameras. Sure, I don't need 99% of the video, but if my dog jumps the fence, it's really important that I know that happened. And not that I know that happened 3 days ago. I need to know that happened now. So this gives us a need for a very high level of accuracy, even though we don't have much training data or examples of what we're looking for. And with that, we get a full workflow, starting from a large varied data set getting an understanding of what we have, narrowing it down, and finally enabling some efficient summarization and activity detection of these more focused sets of videos. The last thing I'd like to cover is one particular research area that covers the whole workflow, and that's user interfaces and experience. We're interested both at a broad level and with more focused data sets of being able to alert analysts to new content that's of interest to them. This could include things like anomaly detection. We also want a personalized search. This could be based on what we know about the user, or as mentioned before, taking advantage of any examples they find or the data they focus on. And finally, to enable active learning, we need ways of gathering feedback that don't require the user to manually give us direct input. So we're looking for passive methods that give us what we need to improve search with active learning without getting in the way of the analyst's normal workflow. I know that was a lot. With all that said, if you're interested in learning more, feel free to check out our website, email us directly at lasoutreach@ncsu.edu, or sign up for office hours. Thanks.